Hello, everyone. Thank you for joining today's webinar. Today, I'm going to be talking to you about how you can monitor Databricks tables with SODA. My name is Tyler Adkins. I'm a customer engineer at SODA. You can feel free to ask questions in the chat. And if I see them pop up, I'll try to answer them as I go through this. And if I don't see them, I'll look at them at the end and leave some time for questions and answers then. So the agenda for today's webinar is here. Today, we're going to start by showing how you can easily connect to your data with SODA. And this just takes a few seconds, a few clicks in our UI to connect to your Databricks SQL data. Next, I'll show how you can discover data problems using our automatic profiling and metric monitoring dashboards. And finally, I'll show how you can begin to work on improving data quality by specifying and enforcing your data quality requirements with our no-code interface. So connecting to your data is very easy. You can do so here through our UI, like I'm showing on the screen. So you just need to get some info from Databricks, like the host name, the HTTP path, and then generate a token, put that info in here, click save, and you're good to go. Some of the things that you'll get out of the box as soon as you connect to your data is some profiling. So all of the columns in your tables can be profiled, and we'll get information about how many distinct and missing values there are in the data, some descriptive statistics like the min, max, mean, and standard deviation of your data, as well as histograms that can show extreme values in your data set. And for categorical columns, we can also see frequent values here and in some cases infrequent values, which we may want to take a closer look at. Also, you'll get this out of the box, which is our metric monitoring dashboard. And so here we're going to calculate some key metrics from your data on a daily basis and track those measurements over time and use machine learning models to predict whether the measurement is anomalous or expected. So here we're going to look at things like the amount of data that's added to the table each day, the freshness of the data, and some characteristics of the columns, such as the average values of the columns or the amount of missing data. Here's a look at one of these data set level monitors. Here we're looking at row count each day. And you can see that most of the time the row count is around 200, and sometimes it's very large or very small. And this can be detected by our machine learning models. So using those observability features, you can start to notice things that are happening in your data that may be problematic. And then you can proceed to establish your data quality requirements using our no-code interface, and then begin enforcing those requirements on your data. So here's just showing some examples of where I've created a missing data check and a validity check through our UI. And once we have our checks in place and they're running on our data, we can start to monitor over time, how is the health of our data evolving? All right. Now I'm going to jump into the live demo here. So that was kind of an overview of all the things that I'm going to show today. And now I will show them live. So here's the place in our UI where you can connect your data. You're just going to give a name for your data source. Here you're going to select a SODA agent. The SODA agent is a Kubernetes application that establishes a secure connection to your data source and also helps to orchestrate all of the scans that you'll be setting up. And so by default, SODA can host this agent for you, or you can host it on your own environment. That way there's no connection between SODA servers and your data. And here we can set up the schedules for our default scans, our scans for our data quality checks, scans for profiling, and scans for our anomaly dashboard. Next up, we're going to fill in some information that we got from Databricks. In particular, we're going to need to specify the catalog and schema of our data, and we can get the host and HTTP path from the SQL warehouse that we're using for our data. And then finally, we need to put in a password, and we can get that here by generating a personal access token. There's some additional optional settings here where we can specify exactly which tables we want to profile and monitor. But by default, we'll just include all of them. Once we save this data source and create this new data source, it's going to run some of these automated scans. It's going to discover all the tables in this data source and their columns. So let's jump into some of the things that we're going to get out of the box. So first, we'll see this profiling dashboard here. This is for one of our specific tables that was discovered. So I can see for each column, what's the name of the column, the data type, number of distinct and missing values. For a string type column, we're going to get some statistics like the min and max and average lengths of the strings, frequent values. For numeric columns like this one, we're going to also get some more descriptive statistics here about the min, max, average, standard deviation, sum, and variance. We'll also see a histogram here showing the potential extreme values in our data. This column here is a categorical data. And so we can notice like what are the frequent values and rare values here. And the nice thing about this profiling is that we can immediately start to identify areas where we may want some data quality test coverage. So for example, in this ID column, we see there's 98 missing values. So maybe we want to have a missing data check for this column. Or for this latencies column, we notice there's some extreme values over here. Maybe we want to have a validity check to make sure that we are notified whenever these extreme values show up. And similarly for this responses column, this categorical variable, we notice that there's some rare values, and we may want to enforce a requirement on this column that will notify us when those rare values are detected. So that's the profiling. Also out of the box, we're going to get this metric monitoring dashboard. Here we're going to use a combination of metadata from Databricks as well as the actual data to track some key metrics about your data set over time. So for example, we can look each day at the row count, like the daily row count, and take those measurements. And then underneath, we can train machine learning models to learn what is the expected range of values for that measurement. You can see here, I'm just showing 7 days, but we can look past 30 days, 60 days, 90 days, even up to a year. And we can do this immediately after connecting to our data. So we don't have to wait a year to see a year of results here. Because the data is already in our table, we can retroactively query the historic data to give you some instant results. So let's look a little bit deeper into this visualization here. So we can see most of the time, the number of daily rows is around 200. On some days, there's more, like 500 or 600. Other days, there's less, like somewhere between like 0 and 10. And those are detected here as anomalies, which is what we want. But we can further customize this anomaly detector. For example, maybe we want to ignore the lower bound anomalies and just detect anomalies up here. Or maybe we want to exclude certain values. Or maybe we want to just directly adjust sensitivity. And here we can see a simulation of what the impact of this adjustment would be in the past. Down here, we can see a table of those same results. Some other metrics that we're monitoring include the freshness of the data. This is looking at the most recent timestamp. We can also monitor some key metrics from the columns as well, like the average values, the amount of missing data. And for all of these monitors, we can opt in to receive alerts when an anomaly is detected. By setting up a notification rule here, I can have any anomalies detected here be sent to a specific Slack channel or email or Teams channel. So if we start from this observability dashboard here, this is just stuff that we get out of the box. It's not really setting fixed requirements or enforcing specific data quality requirements. We're just getting a glimpse at what our data looks like and how it's changing over time. Now, what if we want to specify some more concrete requirements? Well, we could start from our profiling tab here. For example, we notice that there's some missing data in the ID column. So we can add a missing data check easily through our UI here. For example, ID is not missing, could be a requirement, pick the ID column, and then we can add the check right away. And now this check will start running once per day or whatever schedule we choose. And we can see the results. Another check we might create is a validity check. For example, this latencies column had some extreme values. We can check those here. So we could put a valid min and max on this column. And then we'll be notified whenever values exceed this max here. So let's add this check. So it's running this check for the first time, and then we'll be able to see the results right away. See, there's quite a few extreme latencies that were detected. You can see the logs of the scan here. And down here, we can see a sample of the actual records that are failing this check. And this can help us to try to get some further insight about the root cause. Also, whenever this check runs, we'll see a notification pop up in Slack, like here. We can see this alert telling us that this particular check is failing. Let's go back to the profiling and create a few more checks. So we could also create a missing data check like I showed. I never actually ran that one, so let's run it. Okay, we see there's 1,123 missing IDs. We can see a sample of those missing IDs here. And once again, we'll see an alert show up on Slack telling us that this requirement is failing. And once we have a lot of requirements in place on our data set, we can see them listed out here in our datasets tab. We can also see some widgets here showing us some high-level information about this table, like the amount of checks that are on it, how the health of the table is evolving over time. We can see in this case, the health is 88%, meaning that 88% of the checks are passing. And we can see that this is improving compared to yesterday. It's a 1% improvement. Here we can also see a calendar of any tickets that have been reported about this table. And so we can also create incidents here. If we have a recurring data quality problem like this one, like ID is missing, we can go ahead and create an incident here, describing the problem. And then we can link our check results here, create the incident. And if we have an integration set up with something like Jira, then this will also create a ticket in Jira. We can see a link to that here. And then at this point, I can assign this task to other people within my organization, and they can work through the investigation and resolution of this data quality problem. All right. Those are the main things that I wanted to show today. Let's see if there are any questions in the chat. I'm trying to see if I can view the chat here. Looks like I can only see the chat for the panelists. But if there are any questions, feel free to raise them. There's a Q&A. Oh, I see. There it is. So one question is, why is Kubernetes used? Kubernetes is used for the SOTA agent because you may have many scans running in parallel. And so Kubernetes will have the ability to spin up pods as needed to handle the running many scans. Where to host this SOTA application? So the UI here that I'm showing, this is a cloud offering. So this will be hosted in SOTA servers, but then that SOTA agent can be hosted on your own environment. And then, of course, your data will always stay in its source. So your data will never be required to leave your environment. It's going to stay in Databricks. And if you have a self-hosted agent in your environment, that will be connecting directly to your data. And then all SOTA is going to do is receive the results of these checks. Thanks for the questions. All right. I do want to bring to your attention the next webinar, which is coming out in a couple of weeks, May 21st at 2025, 12 p.m. Eastern time. This will be kind of taking up where I left off and going a bit deeper into what you can do with Databricks and SOTA, specifically how to catch data issues early in Databricks, so putting checks into your pipelines and being able to prevent data quality problems from propagating downstream. All right. Thank you all.